Hello students. In the last lectures, we have studied about the time varying fields. The introduction of time varying fields, Faraday's law, displacement current, and also Maxwell equations for various fields. Now, in this today's lecture, we'll discuss about uniform plane wave. So before going to the into the uniform plane wave chapter, let us go through the introduction of this uniform plane wave. We know that Maxwell equations for the time varying fields forms the basics for the explanation of electromagnetic wave propagation, and also the existence of electromagnetic waves actually was first stated by Hertz professor. Actually, Professor Maxwell himself predicted the existence of electromagnetic waves earlier, but Professor Hertz was the first scientist who has generated and detected the radio waves successfully. So sometimes EM waves are also commonly called as Hertzian waves. So what do you mean by actually waves? Waves are nothing but what means of transporting energy or information from source to destination. The waves which consisting of electric and magnetic fields are called as electromagnetic waves. The electromagnetic waves are said to be in existence if all the four Maxwell equations are satisfied at the source point, at the medium, and at the destination. Basically, waves radiated from the source are with a spherical wavefront. So but a large distances from a source, the spherical waves becomes practically plane waves. Hence we can tell that the plane waves are nothing but uniform plane waves. So in general, wave is nothing but a function of time and space, right? So in this chapter we will discuss the analysis of Maxwell equations to derive the equations of EM waves in the following media, such as free space, where epsilon naught is equal to epsilon, mu is equal to mu naught, and sigma is equal to 0. That is for free space. And perfect, that is nothing but, second one is a perfect, that is nothing but lossless dielectric, that is sigma is equal to 0 and epsilon is equal to epsilon r epsilon naught, mu is equal to mu r mu naught, and sigma is very less than omega epsilon. And third one is a lossy dielectric, where sigma is not equal to 0 and epsilon is equal to epsilon r epsilon naught, mu is equal to mu r mu naught. And last one is perfect or good conductor, so there is nothing but epsilon is equal to epsilon naught, mu is equal to mu r mu naught, and sigma is very greater than omega epsilon, and sigma is equal to infinity. So this chapter is concerned with the applications of Maxwell equations to the problem of electromagnetic wave propagation. In this study, we'll explore the basic principle of electromagnetic wave propagation. We will come to understand the physical process that determine the speed of propagation and the extent to which attenuation may occur. And also we'll derive and use the Ponting theorem to find power carried by the wave. So here these are the things we are going to study. That is, first one is, it is nothing but we are going to concern with application of Maxwell equation, and second is we will explore the basic principle of electromagnetic waves, and also we will study the physical processes that determines the speed of propagation, and last one is we are going to determine the use and derivation of Ponting theorem and also power carried by the wave, right? So if you want to see this electromagnetic waves in the block diagram, in form of block diagram, you can see here. So electromagnetic waves are nothing but they are classified into plane waves, Ponting vector, and plane waves in the various medias. So first one is a plane waves. Plane waves can be polarized, so the nothing but polarization. And plane waves in a various medias means what? It can be have a lossless medium, that is in a dielectric medium, lossy conducting medium, good conductor, and good dielectric. So this is a classification of classification of what electromagnetic waves. So hence you can see in this block where we can have electromagnetic waves are classified to various forms. Plane waves you can have do the polarization are also Poynting vector, and also you can have plane waves in the various mediums like free space, perfect, dielectric, lossy dielectric, and perfect or a good conductor. So this was about the introduction of uniform plane wave. So in the next classes we will see about some of the next section of this chapter about the uniform plane wave. Thank you.